Slide. For propulsion, it expels gases from its rocket engines at a rate of 10 kilograms per second. So that's somewhat like a velocity, but not really. But I'm going to just write it in there like that. And an exhaust speed, so this is a velocity, of 2.5 times 10 to the 4th meters per second relative to the rocket. For how many seconds must the engines burn in order for the sled to acquire, so I need a V1, 0 meters per second, V2 is 50 meters per second. Looking for A, and over a given amount of time. Alright, so there's all my information that I'm given. Okay, so in any one of these questions, generally what am I using to find my A, or what have I been using?
Force.
And what is force usually equal to?
Mass times acceleration.
Okay, so that's what we have to start with. Force is equal to mass times acceleration. Okay? Alright, so, Campbell, where do we go from here? We had to switch this equation somehow. What did we switch that equation to?
So, the way I have it here is we have the V2 equals V1 plus the AT, and then we have that switched to V2 equals force over mass times T, and then it's...
Okay, just a second, go slower. V2 is equal to V1 plus A delta T.
Yeah, and then...
Okay, so, but V1 is 0, right?
Yes.
So then V2 is equal to A times delta T. So this, I'm working with this right here, so far. Okay? V2 then is equal to, what can I use instead of A, because I don't know A?
Force over mass.
My force over my mass. Okay, so this is a higher end, we haven't done this yet. So what I'm doing is V1 is 0 here, right Mary? So I'm looking at this here. How do I solve for T? Okay? I need to find A, right? But if I knew what A was, I just simply find T by changing around this equation here. Okay, T would be equal to V2 minus V1 over A. Change in velocity over acceleration. So far that makes sense? Okay? My V1 is 0. My force over mass and my time. I know what V2 is. What's V2? V2 is 50, right? So then it's up to me to find out what the force is here. So to get the force, what do I need to do?
Find the.
Because I know mass, right? So I've got to use that somehow. And again, I use this, I don't like the way I wrote that, but I've got this 10 kilograms per second. All right? And I have a velocity of 2.5 times 10 to the 4th meters per second. So that's my exhaust, right? So it expels at 10 kilograms per second. So what did I do right here?
You multiply that by the 2.5 times 10.
Okay, so just gonna make this smaller for a second. So focused on this part right here. If I take my velocity and I multiply it by the rate at which I expel that gas. Okay? I'm going to end up with the amount of force, because I'm gonna end up with kilograms meters per second squared. So that's the catch in the whole question, is to get the thrust force, I need to know how fast the velocity, how fast the gases are expelled, and the rate at which I'm expelling the gases. So this gives me 2.5 times 10 to the, oh, I missed something here, that's 4, right? So this give me 2.5 times 10 to the 5 newtons. So this is the part of the question that we haven't done anything with until this question. It's the only question that we do it with. All right? So now you just substitute this value in for F. That's your M, and then you solve for T. Okay, Mary? All right. All right. Others today.
Question 16 on page 327.
Okay. What information are you given here? Last one is 900 kilograms. Okay. What else are you given? Okay, so M2. Okay. So far so good, right? You know anything else?
My time for A is 2 seconds.
What else do you know? I don't think we need, I don't think we need it yet.
That's all I used in the first one.
We're missing information. Lexi?
Oh, my V20.
Okay. That's the most important piece of information right there. Okay, so far so good. And we want to find the steady force which acting on the cannon will stop its recoil in 2 seconds. So you're looking for force. Okay, so have a look at the board here.
So I found my acceleration.
You don't need your acceleration for this question. What is impulse?
Oh, force times time.
And what is that? What else is impulse equal to?
Newton's times.
What?
Newton's times.
No.
M2 plus V2 minus M1 plus V1.
What is that?
Momentum.
Yeah, change in momentum.
So if you change momentum.
Change in P is equal to impulse. You're going to use that after to get your velocity of your cannon probably. You don't have A. How did you get A?
I had my everything else but it, so I just solved because my time is 2 seconds. V2 and I just.
And what else did you use?
Well, I have my V2 0, my V1 as the 250. And
Yeah, but you're talking about two different things. You're talking about the cannon and you're talking about cannonball. So those two velocities are for two different things,
Oh, okay.
right? Like these go together and these go together.
Well, my V2, my bullet is always 0 because it has to stop eventually.
Yeah, but there's nothing affecting it horizontally. Only gravity affects it. So you'd have to go through the question and you'd have to find out how high the cannon is. And then you'd have to, so you're not going to do this using that method. Okay? Yeah. Other questions today?
Number 18 on the next page, page 28. Yep,
When a person parachutes, the impact velocity is equal to that attained in a free fall from a height of 4.5 meters. After contacting the ground, the jumper's momentum is quickly brought to 0 by the earth. What is the impact velocity? Alright, let's read the question again. So when somebody jumps out of an airplane, alright,
alright,
and you have a parachute,
yep,
you hit the ground
yep,
with the same amount of speed as if you were to jump off a 4.5 meter ladder, let's say.
yeah,
Okay?
okay,
So you're going to focus on just the 4.5 meter ladder and how you find out what the V2 is. So what's your V1 when you're jumping off that ladder?
0,
Okay? So my V1 is 0. What else do I know?
distance is 4.5,
Okay. What else?
acceleration is 9.8,
You have enough information here to now find your V2?
yep,
Is the acceleration still 1.8 if the parachute's already open?
You're misunderstanding the question. The question says that if you hit the ground using a parachute, it's the same impact velocity as if you were to jump 4.5 meters without anything. It says free fall for 4.5 meters.
Oh, okay.
So do you have a parachute on when you're jumping?
No.
No. So is the acceleration 9.8? Yes. You get it? Okay. All right, Morgan, can you do this now?
yep,
Okay.
Okay.
Do you need more help with that question, or are you okay then?
I just use one of those equations and
Mm-hmm.
let me all know.
Okay. Anybody else have questions today?
That's what throw with number 17.
And you ask it first. Okay, let's start by going through the information that you know. What do you know?
I have a mass of ball is 300 grams, that's the mass of the ball. Its impact time is 0.020 seconds. There's just an initial speed of 50 meters per second. And a second speed of 100 meters per second.
You know why I put that there?
Because going the opposite direction.
Yeah. So I want you to calculate the average force. So switch this out. Make that B2. Mass of the ball doesn't change, Morgan.
Yeah, I forgot about that part, about the ball, or the mass.
Okay,
Because
so now I'm using impulse again. How do I find impulse?
M times, M1 times V1 plus, no, take away, let me think,
You're doing okay, Morgan. M2, B2,
yeah,
subtract M1, B1. Because that's change, right?
right,
Anytime you use change, you have final minus initial.
yeah,
M2, B2 minus M1, B1, right?
right,
And that's equal to.
yeah.
You have all the pieces there that you need.
The mass part, I messed up. And that's, I knew that a 100 was negative, I tried with negative and I still did it wrong. So, I think I said it wrong now.
Okay. Anybody else have questions today? Yeah, Calvin.
Page 314, 3A.
Is this the one that goes back to question 2 on the other one? No? Okay, no, I understand. All right, everybody want to watch this? The two ways that they can ask you the bomb question. All right, let me go back to something. When we were looking at forces and pulling a sled, there was two ways in which they could ask you how to do the sled question. The first way was to actually give you the angles of each, so 20 degrees here, 40 degrees here, let's say. The second way they told you to use that question is if they gave you the entire angle. So we had to do both those questions differently. This one here I could use right angle trig for and solve it, right? This one here, I needed to take this vector here and stick it on the end over here, like so. And then I needed to find out what that was. We all recalling this now? Okay? So there's two ways in which they're going to ask you the exploding question. The first way is to give it to you in directions. They'll tell you the actual direction and the momentum of the first two pieces. The second way they're going to do it is they're going to tell you how far apart they fly, or what angle they fly apart, which is the same as this. So basically what I'm saying to you is the two questions will be very, very similar. This way you'll do it using components if you want. This way you do it using law of sines and cosines. Question 3 is the same idea. Okay? Now you can make the angles in this question whatever you, not the angles, but the direction, whatever you want it to be. Alright? A bomb initially at rest on a smooth, frictionless, horizontal surface exploded into 3 pieces. Okay. So, my momentum before is what? 0. It's not moving, right? And then I have 3 pieces after the fact. Okay? So, 2 pieces fly off horizontally at 60-degree angles to each other. A 2 kilogram piece at 20 meters per second, a 3 kilogram piece at 12 meters per second. The third piece flies off horizontally at 30 meters per second. Okay, so what am I missing? When I read this question, what's the first thing that you notice I'm missing? Yeah, I'm missing, that's right. I'm missing the mass of that third piece, aren't I? Okay, so at some point I have to figure out how is this going to help me and what am I going to do this direction of this third piece. Okay, so if I'm solving this, and I know this is 0, right? So I have P1 plus P2 plus P3. Therefore, P3 prime is equal to. Again, it's dependent on what you are most comfortable with. Alright? I would personally go negative P1 prime plus P2 prime, like that. Okay, to me, it's easier if I do it by adding the two pieces together. That's the easiest way to do this question. Okay, so it says piece 1 flies off. It doesn't matter how I do it, but it flies off in this direction. So this is P1 prime. P2 prime flies off at a 60-degree angle to this. But knowing what you do from that other sled question, what do I need to do here? Yeah, I need to move it and put it to the tip of this next one. So I'm going to change this. I'm going to move this over to here. That's there. This goes up. That's 60 degrees right here. Just going to erase all of this. Okay. So this is P2 prime here. So I have now added P1 prime and P2 prime together. All right. And what am I getting right here?
The distance between.
No, not distance, no. P3 prime, right? Because I'm using these guys here, right? Right, so I have P3 prime, but is that actually P3 prime or? Right, so when I calculate my angle here, I have to switch the direction of it. Is this making sense to you so far?
Yeah.
Okay. Now that you see this, can you do the question?
Yeah, I did it that way. I
Okay.
got the mass, but
So you didn't get something right?
I didn't get the direction.
Okay,
right
so let's,
afterwards.
well, why don't we just, let's start with this. Okay, so P1 is, what is P1?
40?
40? Okay, and P2 is
36.
36 kilograms meters per second. Okay. All right, so I have to find this P3 prime first. And that's actually negative P3 prime, so I'm going to write that in there. Okay, so this is the part I feel like 90% of you are not going to understand how I go from here to here. All right? Because of this right there. Because I moved both of those to the other side. Realistically, if I wrote this, this is what I have right now. This is what I have drawn right now. The negative P3 prime. So what I did is I actually moved this to that side. Okay? So that's how I get negative P3 prime over here. When I'm doing my components, I write it like this, or I write it as negative negative. When I'm doing it, when they give you the angle in between, I move my P3 prime over to get to here. And then I'll switch my angle after the fact. All right, so what did you get here?
65.848.
So that's 120 degrees, right?
Yeah.
Okay, so you got 65.848
848.
kilograms meters per second. All right, just for the heck of it, let's find out what the mass is using that, just to make sure we got it right. So divide that by the speed it's moving at.
30.
30, thanks.
Yeah, 2.195.
Is that what you get? Is that the right mass?
Yeah.
Okay, so we know that that's right. Okay, so now I'm going to go sine alpha over, is that 36?
Yeah.
Can't read my own writing. Okay, and then sine of 120 over 65.848 alpha equals.
So,
Go ahead, Ray.
sorry, how did he get 65? Did he?
Law of cosines. 40 squared plus 36 squared minus 2 times 40 times 36 times the cos of 120.
Oh, okay.
Did you have the cos of 60?
Yeah.
Yeah. Do you see why it's 120, Mary?
Yeah, I know why.
Okay. Okay, good. Alright. Campbell, what'd you get?
28.260.
Let's see. Okay, so that's that angle right there, right? Okay, but that's not the direction the third piece is moving, because the third piece isn't going that way. So if I extended this out this way, that means that this is also 28.260, right? So then my angle made with the first piece would be that right there. Okay, now you, in theory, you could also use that angle right there as well. They both work. So what is the angle that they actually give you as the answer?
148 counterclockwise from the 3 kilogram piece.
So from right here, well, this actually would be, yeah, it is right. It would be 148. 148? 140,
It says 148.
they say 148?
I got it.
I feel like this should add up to 180. Go ahead.
I thought when we did the negative P3 that we take the angle on the opposite side.
That's what I did here.
But isn't that the normal side? 'Cause
No,
it's
this
negative.
is the angle that I've got it going right here.
Yeah.
So negative P3 is the opposite direction, it'd be over here.
So still find the angle, but then you just switch direction.
Yes.
Or what is it to do on the other side? Same angle, but not less stuff. So if you don't change your direction, can you use the other angle?
Change your direction, can you use the other angle? You can use this angle or this angle. They're both correct. Okay? So, alright, let's see. I still don't think that doesn't jive. I feel like that should be 142.
The answer key says 148.
Okay, well, let's have a look. Let's have a look at this here. What page is that?
314.
14. Put this in the page. You're on the page there, will you?
Yeah, I've got 28.26 plus that 120, you got 148.
Added to the 120?
Yeah, and then you get 148.
Yeah. Okay, I'm missing that page. I don't have that answer here.
Why would you ask them?
Okay.
Yeah.
Alright, so let's have a look here. Let me redraw this. Okay, so that was 28 degrees, which means then, I'll try and draw this a little bit better and see if we can figure it out. So, just based on extend this down more to here. Pretty sure this figures out.
120.
Yeah, I think it looked pretty good though. Make that look like 120. Okay, so if I keep this going in here, okay, and I extend the red guy like that. This is 120 degrees right here, right? And this is 28.260 right here.
Thank you.
That means means then that this is 28.260 right here, right?
You move the blue line to where the red and green intersect, because it's
Yeah.
a grenade, they all explode from the same place. Then between the red and the
Ah.
blue, you get 120, and then you have clockwise.
Yeah,
from the
okay,
3
so-
kilogram piece, so they
Alright,
follow
so
straight
yeah,
up.
they're all exploding from right here, right?
Yeah.
Yeah, okay, and then this is 60 here, which then means then that this is 100 and... Just gotta figure out my size. No, this is 60 right here. Right?
I think that would still be 120.
Maybe 120 that one.
Oh, no, so it's 120 right here. This would be 120.
So then it would be 148 clockwise from the 3 kilogram piece. But the answer key says counterclockwise, but they must have just drawn it the other way.
Yeah. Yeah, they could have done, that's right, because they could have done 60 any which way. Okay. Anyways, so that would be that right there. Be 148. Alright. I'm not going to make that as complicated.
Number 3,
Number 3.
are you just gonna do like the ones you did before?
No, you'll get one like it, but it won't be, I'll do it such that you have direction, like you can label your own direction. And it's easier to do that rather than say 20, because like realistically, if you wanted to do this, you could say, if you were saying that this went, northwest, like if you made it happen where it went northwest
That's not
and doing whatever, like you can make that happen. So I'll allow you to say, okay, it's 28.26 degrees. If I was going, my way of doing it would have been this, right there. I would have used that and said it's going, that's counterclockwise. That's, so I would take the red, whatever that would be, 180 minus that, and get that, so. We'll be a little more flexible with that, is my point on this. Okay? Alright. Anybody else?
When are we gonna start watching that movie?
I
Yeah.
don't know. We gotta finish this first. Okay, any other questions here? Are you guys done?
I'm on the review.
How far are you?
My only question 18.
Are you just getting into the review?
Yeah.
Me too.
Okay, so you're gonna need at least 2 more days of this. Okay, so we'll work on this through Friday. Maybe Monday, Tuesday, we may look at that, possibly look at that movie. And then, that's Monday, Tuesday, Wednesday we'll likely test on this. Any question?
Yeah, it's just a general question. So if the bomb, it wasn't moving, so it's 0. So if you started throwing it, you have to do that V.
So the difference is this. Okay, so Kelsey's question is, what happens if the bomb is moving? So there should be a question on there that uses that example that we used. Yeah, 314 question 2. So the one right before the one we just did. Okay, so what happens here is simply this. If I'm looking for P3 prime, okay, and I have momentum ahead of time, all I do is do this. That's the difference.
So you just.
So if there's momentum before, the P stays here. Okay, it's actually easier to do it this way than it is when it's 0. 0 seems to confuse everybody because of negatives. When I actually have momentum before, it works better. Okay? All right. So you got the next couple of days, keep working on all of that then.